We are ready to look at natural killer cells, and I leave this to the end partly because they don't fit perfectly within innate or adaptive. They have completely innate characteristics, and I would like you to think through, what is an innate characteristic? What do all the innate things have in common? And really, it's that they're kind of hardwired to do a job, and they do it when they recognize certain things that they're programmed to recognize, and all of them recognize the same things. Like, macrophages all have the same pattern recognition receptors. Natural killer cells are all going to do exactly the same thing. Compare that to a lymphocyte. A lymphocyte has a whole bunch of copies of one completely unique receptor no other cell necessarily has. And that receptor is randomly generated. That is adaptive. The adaptive system includes those randomly generated lymphocyte receptors. So if you're asked, is this innate or adaptive, really you should just think, are there randomly generated lymphocyte receptors? If the answer is no, then it's not adaptive. So natural killer cells are not adaptive. So their job is to kill host cells that don't display MHC-I. So why would that be useful? Like, why would a cell not display MHC-I? Our cells always display MHC-I because if they're infected by a virus, or if they have a weird cancer thing going on, that lets cytotoxic T cells see it. And that cell wants to take one for the team and get killed so that the body doesn't die. So MHC-I is constantly protecting us from viruses and cancers by showing the inside of cells to cytotoxic T cells. So it turns out that a lot of viruses shut down the MHC-I system. They have signaling proteins they release that confuse it and shut it down. And some out-of-control cells, cancer cells, will forget to make MHC-I. They get all these mutations that are powerful, and a really powerful one would shut down MHC-I. And so this behavior puts cytotoxic T cells out of the game. They're never going to see their receptor, they're never going to see the epitope they're specific for, because they're not going to see anything. So the cells cytotoxic T cells would normally kill aren't going to show them anything. So that's why we have natural killer cells, because we have to be able to kill the cells that are avoiding the cytotoxic T cells. So any nucleated cell in your body that doesn't show MHC-I is probably abnormal. It's probably infected by a virus or cancerous or something. And so natural killer cells look for that, and they kill the abnormal cells. So in a real way, your antiviral response to COVID-19 is back and forth between cytotoxic T cells and natural killer cells. They work together in a really powerful way, and they kill cells the same way. They just find the cells in completely different ways. Cytotoxic T cells are adaptive. They're perfectly specialized to attack cells that show one specific epitope, and they're the only cell that can see it. Natural killer cells are not specialized. They all do exactly the same thing. They look for cells that don't show MHC-I, and they kill them. And it's elegant. This can protect you from tumors. Right. So this is just another drawing of this kind of thing. This is what's often taught in immunology classes, that the natural killer cell has two major receptors. One of it is the activating receptor, and it finds a molecule that we haven't talked about that just shows that this is a cell that should display MHC-I. And so the natural killer cell sees that and is like, ooh, I'm dangerous to you. I might kill you. And the only way this cell is going to save itself is by quick showing it MHC-I. and then the natural killer cell will detect that and move along. But if this doesn't happen, if there's no MHC-I, then boom, this cell dies. And there's like a combination of apoptotic signals and other things that natural killer cells and cytotoxic T cells use to kill host cells. We don't want to like break our own cells open, because that releases lactic acid and other stuff that really freaks out the immune system. That's going to cause inflammation very fast if we have lysed cells. So we don't do that. We just tell them, die, break into pieces in an orderly way. And they do, generally. So this just tells that story again. And that's it, really. We're at a point where we can go through a whole bunch of review, and these slides are slides I recently made so that you can do this review. You can use these to test yourself. For example, can you list the effector cells? Well, here they are. Can you do the life stages of a lymphocyte? This is, important, right? Can you describe the function of every type of cell in the immune system and all the different life stages of a lymphocyte? If you can, you could write these slides. And then there's some curiosity stuff. At this point, it's all curiosity stuff and you can skip it. I'm just going to run through it quick. There are just some clips where people who are trying to develop vaccines are really at the mercy of T cells, the helper T cells, and the ratio of type 1 to type 2. And they're just some examples of that. And then these are slides about herd immunity and what it is, and how it can limit outbreaks. And this is, at the start of the COVID-19 pandemic, a lot of people wanted to just use herd immunity, and this is why that was not a good idea. People who didn't have all the information were asking for herd immunity. Knowing what we know now, that was an insanely bad idea. But they didn't have this information. And how could we have gotten herd immunity to work? How many immunized people would we have needed? We don't know. Vaccine skeptics. Nothing in here is meant to change a vaccine skeptic's mind. Nothing I could say would change a vaccine skeptic's mind. They're going to say, well, you're one of those science people, right? And if they don't trust me, they don't trust me. But what I want to say is when I hear a claim, this is part of what goes through my mind. An extraordinary claim requires extraordinary evidence. If somebody's going to say something crazy, they need amazing evidence. And somebody saying, I don't trust companies, I don't trust pharmaceutical companies, so I don't want a vaccine, well, that's not an extraordinary claim. I'm not going to argue with them. That's perfectly reasonable. I don't trust the government. Fine. They don't trust the government. That's fine. But when they make up all this stupid stuff about like magic and radiation making viruses, well, they need really good evidence, or else they shouldn't be taken seriously. Whatever. This is how mRNA vaccines work. I looked up whatever I could find about it, and then some things you'll hear on YouTube about the immune system. Another thing natural killer cells do, and this shows you how kind of crazy the adaptive immune system is. And that's it for the immune system. You made it to the end of the slides. Hopefully you can see why this gets spread out over 2 weeks. It really needs to be spread out over 2 weeks. There's no way to learn this overnight. There's no way to cram the adaptive immune system. There are just too many pieces you need to have. So, good luck, and I hope to see you soon.